Okay, so that last example on example 4, let me go back to it. Wasn't so bad. Oops, sorry. Wasn't so bad. We had to find 4 terms, add them up, not too painful. But what if we had more terms? What if we had 10 terms, or 50 terms, or a million terms, or infinity terms? We'll talk about infinity terms next time. But to shorten this process, there is a pattern that we can use here. So the partial sum s sub n of the first n terms of a geometric sequence. So like if we're doing 50 terms, n would be 50. It's a sub 1 plus a sub 2 plus a sub 3 plus all the way until you get to the end. So if it was 50 terms, it'd be the last one would be a sub 50. So it's going to be s sub n equals a sub 1 times 1, or the group 1 minus r to the n over 1 minus r, as long as r is not equal to 1. If r is equal to 1, it's not really a geometric series. In fact, it's just a constant series. It means you'd be multiplying the first term by 1 to get to the second term. So it's the same number. Multiply that by 1 to get to the third term. So we just don't want to do r equals 1 because it's kind of boring. It's just a constant series. We're not really interested in that right now. But again, a sub 1 is your first term, r is your constant ratio. We're going to use this on the last example here and see how we can find this, or see if we can shorten the process. So we're asked to find the indicated sum of each geometric series. Again, the formula we're using here is s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We got to figure out some things here. We need to know what n is. We need to know what r is. We need to know what a sub 1 is. Couple different ways you can go about this. N, number of terms, 6. Start with the first term going up to the sixth term. 1, 2, 3, 4, 5, 6. That's 6 terms. R, taking a look at the pattern here, it's the number that's being raised to the exponent. So in our case, it's just 2. Now, a sub 1, a couple different things you can do. You can do a sub 1, go ahead and plug in 1 into your equation. So we got 3 times 2 to the 1 minus 1, which is negative 3 times 2 to the 0, which ends up being negative 3 times 2, or sorry, times 0. Goodness gracious. Negative 3 times 1, which is negative 3. So, I accidentally erased it. So r again was 2, a sub 1 is negative 3. Again, you might have been able to identify that. Do be careful because your first term's not always going to be this first number here. Say, for example, every once in a while you see like k minus 2 here. So that can throw things off. It's safest just to go through and plug things in. Let's start plugging in what we know. S sub 6 equals first term, negative 3, times 1 minus our ratio of 2, because we're multiplying by 2 every time, to the 6th power over 1 minus 2. I'm going to do as much of this by hand as I can. We got negative 3. 1 minus 2 to the 6th is 64 over 1 minus 2, negative 1. We got negative 3 times 1 minus 64 is negative 63 divided by negative 1. Negative 3 times negative 63 divided by negative 1 is positive 63, which, when we do 63 times negative 3, we end up with negative 189. So the sum of the first 6 terms of this series is negative 189. You can always go through and find every term that I'm asking you to do. So say, for example, you could find the first term, second term, third term, fourth term, fifth term, sixth term. Find each of those individually, add them all up. This formula is a little shorter because all you need to know is first term, ratio, and your number of terms. You don't need to know every term that you're adding up. Just a little quicker.